So we're looking at fetal circulation here. When we look at fetal circulation, you have to remember one main thing. We are not getting oxygen, or the fetus is not getting oxygen from the lungs. Okay, the fetus is actually getting oxygen from the blood that comes from the placenta. In addition to that, you can remember a couple rules that we talked about earlier. Arteries are always going away from the heart. Veins are always going towards the heart. And on these models, what you can remember is red represents oxygenated blood, blue represents deoxygenated blood. So we'll start our pathway down here. You'll notice in the placenta we have these red structures here. This red vasculature is eventually leading into the umbilical cord as the umbilical vein. Umbilical vein comes all the way up in red, carries oxygenated blood all the way through and now into the baby, or into the fetus at the navel. That umbilical vein continues all the way up and underneath the liver meets up with another vein, the inferior vena cava, which is the main vein that leads into our heart. The umbilical vein and the inferior vena cava, because they're two veins, come together and form something called the ductus venosus. The ductus venosus is the duct between two veins. That blood then comes all the way up into the right atrium. Once we're at the right atrium, we can do several things, okay? Like we have in yours and mine, in the adult heart, we can run through the normal scenario, which would be right atrium, right ventricle, pulmonary trunk to the lungs, left atrium, left ventricle, and then up and out the aorta. But just remember, we're not going to the lungs to get the blood oxygenated. Okay, blood just might flow there to actually bring oxygenated blood to that tissue. But as we flow through, it would eventually go all the way down in purple, because we're talking about now a mixture of oxygenated and deoxygenated blood. So red and blue make purple. We have this abdominal aorta coming all the way down. You can see it split into the iliacs. This is then going to feed all the tissue all the way down here. Eventually, it comes all the way back as the umbilical arteries. There are two umbilical arteries arising from either leg, exits the navel, and these two umbilical arteries go all the way out the umbilical cord as the blue lines carrying deoxygenated blood. Umbilical arteries are going away from the heart. That's why we call them arteries. At the placenta, we drop off carbon dioxide, pick up oxygen, and then we head back again. So the umbilical vein comes all the way up through, heads into the body, meets up at the ductus venosus, and then goes to the right side of the heart again. Now, this is where circulation, on this route, where circulation will differ in the adult model different than it is in the fetal model. So what happens here is, in the scenario that I'm going to describe, we're going to bypass pulmonary circulation. So from here, we would go from the right atrium to the right ventricle, up the pulmonary trunk, and then we would go through a structure right here. This is called the ductus arteriosus. The ductus arteriosus is a duct between two arteries. The pulmonary trunk is an artery, the aorta is an artery. So the ductus arteriosus would be the duct between two arteries. Blood has bypassed the lungs, and it will then continue to go all the way down, eventually all the way up the umbilical arteries and back out. Another route, as we come all the way in, back up to the right side of the heart, is we can go from the right side of the heart immediately to the left side of the heart. And we can do that by passing through a structure called the foramen ovale. The foramen ovale is a whole foramen that has an oval shape to it. And this passes from the right atrium to the left atrium. You can see I'm passing the pink pipe cleaner right through here. When we go from the right atrium to the left atrium, we've immediately bypassed pulmonary circulation again. From there, the left atrium to the left ventricle, up and out the aorta, and then again throughout the rest of the body, we then deliver this blood. Now, when we look at these structures in the adult heart, we can still see remnants of them. In fact, if we look at these structures, right atrium, right ventricle, left atrium, left ventricle, if I open up this right atrium and we look inside here, okay, we see the foramen ovale has become something called the fossa ovalis. The fossa ovalis is that scar tissue that each of us has in between the right and the left atriums in our heart. This is what closes at birth and closes off the right side of the heart from the left side. This is what gives us an oxygenated left side of the heart and a deoxygenated blood flowing through the right side of the heart. The other thing we see is the ductus arteriosus. The ductus arteriosus, which was the duct between two arteries, pulmonary artery and the aorta, becomes eventually the ligamentum arteriosum. It is now the ligament between two arteries. So the ligamentum arteriosum and the fossa ovalis are remnants in our adult hearts of what we once had as structures in the fetal heart.